Good morning, students. So today also we have day 5 over here. Why? Because yesterday we could not finish work for energy. So still we are at day 5. So what we are going to start with? Vertical circular motion. Okay. We will see vertical circular motion first and we'll try to finish this today. Vertical circular motion. Yes. Yesterday's test I did not give you because work for energy did not finish. Okay. So this will be finishing today and you will have a test, right? So vertical circular motion, as I told you yesterday, that it depends on conservation of energy. Depends on conservation of energy. Okay, so if you are talking about vertical circular motion, we know that motion will be circular only, but this comes under non-uniform circular motion. Okay, this is non-uniform circular motion. Non-uniform circular motion. Okay, so what it is here? We have a pendulum. And this pendulum we want to make it move in a circular motion. Okay, so what we'll do? We'll give it a velocity over here. So here is velocity is v1. Right, here is tension. And then mg will be acting in this direction here. Right, so what is the acceleration over here? Now acceleration will be because of the forces obviously. You can see tension is upwards and gravitation is downwards. So acceleration is over here, velocity is like this. So at the bottommost point, acceleration, whatever acceleration is there, that acceleration and velocity are perpendicular to each other. So at this point, force is not going to accelerate or retard it. Where? At the bottommost point. Okay, this is bottommost point. So at bottommost point, force is perpendicular to velocity. Okay, so at this moment at least, it's not increasing its velocity. Okay, or decreasing its velocity, both ways. Now if suppose this particle goes here, now what's happening? It's velocity will be something else, say v2. Now here where is mg? Now mg is acting like this. This is mg. Tension will be here. Okay, now mg's component. Which component? If suppose I say this is theta, then I know that mg cos theta will be here in this direction. Which component is there which is in direction with velocity? Mg sin theta. Mg sin theta is acting like this. So you can see that this mg sin theta force is actually trying to decrease the velocity. It's opposite. Decreasing its kinetic energy or decreasing the magnitude of speed. Okay, so you can see that this is, you can say this is tangential force also, or tangential acceleration is g sin theta. Okay, if I say this is point B, then at point B, there is tangential retardation. How much? G sin theta. So tangential retardation is g sin theta here. Let's go further up. Let's go to point C there. See what's happening. This is point C. And here speed will be something else. Why? Because force is acting. Forces and velocity is decreasing as it's moving up. So here velocity is different. Where is mg? G is here. Here is tension. Is tension same throughout? No, tension is also different. Here is T1, here is T2, here is T3. Okay, now you can see that what is tangential acceleration? You can see g. Okay, g. So tangential acceleration or tangential retardation rather has become maximum here. Here its value is g. If this is point C, then tangential retardation at this is g. At point C, tangential retardation is is g. Okay, as you go further up, then what's going to happen? Suppose this point here. This point is D. Okay. Now at this point, what will be velocity? We'll say something like V4. Okay, mg, here it is. Here is mg. Now we have to see that what angle we are taking, because based on angle only we can take the components of gravitation force. Okay, so this is, if suppose now I say this is something like alpha. I have taken this from horizontal. Okay, so if this is alpha here, okay, what will happen? Mg sin alpha will be acting in this direction. It will be like inclined plane, no? See, this is inclined plane. So this will be mg sin alpha. And what is this? This is mg cos alpha. So here, who is trying to act opposite to velocity? Mg cos alpha. So here, your tangential retardation is g cos alpha. Remember, angle is this, not this one. Okay. So at point D, tangential retardation is g cos alpha. So throughout, from this point you are seeing that this gravitation force component is trying to decrease the velocity as it's going up. Right. Finally you say that at point E, see what is happening at point E now. Point E is this. Okay, now here what is happening? Here velocity, let's say, is V5. Okay, mg is acting like this. So in this case, there is no retardation or acceleration. Where? At the topmost point. No retardation or acceleration. Further, if I am taking this point over here, in this one, mg's component will be in this direction only. So from here onwards, acceleration starts. So what will happen? From here to here, velocity is going to increase. Here, it will become maximum because here your acceleration is perpendicular to velocity, or force is perpendicular to velocity. So here velocity is maximum. As it goes up, here force is again trying to decrease the velocity till this point, because here also you see that your force is perpendicular to velocity. Where? At the topmost point. So at topmost point and bottommost point, forces are perpendicular to velocity. At the bottommost point, your velocity is maximum, and at the topmost point, your velocity is least. Okay, so if we have to write relation for velocities, what we will write? V5 is less than V4 is less than V3 is less than V2 is less than V1. V1 is the maximum. Okay, this is very necessary for us to know because sometimes they ask you this tangential acceleration. Okay, so you should be able to find it out. Depending on angle, they will give the angle. Depending on the angle, we should be able to find tangential acceleration. Okay, then what is the other thing they ask? Other thing they ask is these tension values. What is the tension at the top? What is the tension at the bottom? Okay, so how to calculate that? That we will see now. See then, tension. Okay, so first thing is we are going to find tension at the bottommost point. Suppose that this velocity is V1. Okay, and weight of this is mg. Where is mg here? Where will be tension? Tension will be at the top, like this. Now, since it's doing circular motion, then we have to take either centripetal force or centrifugal force. Both we don't take. Both don't exist together. Either we'll be talking about centripetal force or we will be talking about centrifugal force. That means I am saying about mv square by r. Okay. So both ways we can take, there is no problem. But whenever we are having circular motion, we prefer taking centrifugal force in that. Okay, so here also we are taking centrifugal force. Where is centrifugal force acting? We know that it is always outwards. So here is m v1 square by, suppose its length is L, it's m v1 square by L. Then now it's in equilibrium, right? Tension is balancing mg also and mv1 square by L also. So what will be T? T here, let's say this is T1 only, okay. So T1 is mg plus m v1 square by L. You will be saying that why shall we take centrifugal force? You can take centripetal force also, but don't take both. Both are not possible. Okay. So if suppose I take centripetal force, I am just writing it so that you don't get confused. Now centripetal force, how to write? Centripetal force always acts towards the center. Okay, towards the center. So what I will be writing? T1 minus mg equal to centripetal force. What would be that? mv1 square by L. What is T1? mg plus mv1 square by L. Is it same? Right. So we take this is always outside so that you can directly add it. Okay. No need to write the equation. Directly we can. Okay. So it becomes easy. Alright. Then let's go to another point. Which point we are going now? Let's go to this point. Okay. Now here velocity is v2. This is theta. Okay. This is your mg. mg cos theta. Here T2. And then centrifugal force. mv2 square by L. Okay. So what is T2? You can see clearly. T2 equal to mg cos theta plus mv2 square by L. That is it. Right. M3 will write, rather not M3, T3. T3 is here. Velocity is V3. Now is mg going to act over here? No, because mg is acting downwards. Okay, that cannot give tension. So then what will be acting? Centrifugal force only. Here it is. mv3 square by L. So at this position, T3 is mv3 square by L. Who is giving tension to the string? Only centrifugal force. Okay. One more point, two more points are there that we have to talk about. So one more is here. V4. Okay. Here is T4. Centrifugal force will be like this. mv4 square by L. Okay. What about mg? mg is acting like this. mg's component we have to take. So this angle we took alpha, here again we are taking alpha. Okay, so mg's component is here. mg sin alpha. What is T4? T4 will be equal to this minus mg sin alpha. Okay, T4 is equal to m v4 square by L minus mg sin alpha. Okay, topmost point, last point. So topmost point when we are doing is this point here. Say here velocity is v5. Okay, mg is acting down. Tension down. And here centrifugal force. So what do you say? This is T5. Okay, so we'll say mg plus T5 equal to m v5 square by L. So what is T5? T5 is m v5 square by L minus mg. So out of 5 positions, where is tension minimum? Topmost point. Why? Because v5 is minimum. We know that velocity here is minimum first. So centrifugal force also is minimum at the topmost point. and from there your entire weight you are subtracting. In nowhere you have taken entire weight. You see that? Some component, some component. So here entire weight you are subtracting. So tension at the topmost point is minimum. Where it's maximum? Bottommost point. Because V1 is maximum and you are adding mg now. So tension at the bottommost point is maximum and topmost point is minimum. Okay, right? So this is how tension we can calculate in this one. Okay. Now how to talk about velocity? How to calculate velocity? As I said that it is based on conservation of energy. So we will see one or 2 points, not the all now. So at the bottommost point, velocity is v. Okay, then what do you want? We want to calculate what is its velocity here at point P. This point A. This is Vb. What is Vb? Conserving energy. Which energy? Mechanical energy. Conserving mechanical energy. So, kinetic energy at A plus potential energy at A equal to kinetic energy at B plus potential energy at B. Right. So, kinetic energy at A half mv square. Potential energy at A, we have to see that where reference we are taking. So, reference, let A be the reference. This is only the reference. Reference means where potential energy we are going to consider 0. Okay. So, plus 0. Now, kinetic energy at B, that's what we are finding actually, half mvb square plus potential energy at B. So, now when you have to find potential energy at B, we need to know what is this height. Okay, and this angle I have not given, so let's take theta. So, this height we have to find. Now, what this height is? We can see that if this is a right angle triangle, okay, and we know that this is L, correct? If this is L, then this has to be L cos theta. This is L cos theta. So, what we can write? L cos theta plus h equal to what? L, length of the string is L only. This is length of the string. So, L cos theta plus h equal to L. So, what is h? L minus L cos theta. So, that is what we want here, because potential energy at B is mgh only, right? So, this is mgh. Okay, and what we are calculating? Vb square. So, this bring you here half mv square minus mg h. H is this L into 1 minus cos theta. Okay, equal to half mvb square. M cancelled. Multiply 2 on both sides. So, b square minus 2gl into 1 minus cos theta square root equal to Vb. Okay, what I am showing you, not the formula, I am showing you how to apply this. You don't have to remember the formula here. Just remember that conservation of energy throughout we are going to apply. Okay, then find at this point also. This is C point. Okay, so we will find here. Again conservation of energy. What you will write? Kinetic energy at A plus potential energy at A equal to kinetic energy at C plus potential energy at C. Kinetic energy at A we know half mv square. Potential energy at A we know 0. Kinetic energy at C half mvc square. Potential energy at C. Now we know that what this height is. This is L. So here potential energy directly we can write as mgl. So plus mgl. Okay. So half mv square minus mgl equal to half m vc square. The same is cancelled. 2 you multiply throughout. So this becomes v square minus 2gl equal to vc. Okay. Then where else? Where else we have to find? CD also there. This point also you see. Okay, this is VD. Now what? Now this we took alpha. Okay, write it again one more time, same equation, right? So kinetic energy at A plus potential energy at A equal to kinetic energy at D plus potential energy at D. Half mv square plus 0, half mvd square plus potential energy at D. Now you have to find potential energy here. So from here, what is its height? Okay, so up to this we already know this is L. Only this we have to find. So drop a perpendicular. This is L only. The radius is same only, no? L. So this will be L sine alpha. That is it. So height of this point is what? H plus L sine alpha over. So mg to L plus L sine alpha. L plus L sine alpha. Okay. Now what? You can cancel M. Bring this one here. V square by 2 minus L into 1 plus sine alpha equal to Vd square by 2. Multiply 2 both sides. V square minus 2L into 1 plus sine alpha square root equal to Vd. Velocity at D. Okay. Now one more thing is left. Last one at the top. Now this is the easiest way because in this one there are no alphas and thetas, right? So this is velocity at the topmost point, Vt. Okay, let's do this also. Yeah. What is left out? Okay, in this one. Yeah. This G, I didn't bring it here. So G and G, right? Okay. Okay, so Vt, again same, kinetic energy at A plus potential energy at A equal to kinetic energy at B plus potential energy at B. Okay, half mv square, 0, kinetic energy half mvt square plus potential energy. Now you know this is L, this is also L. So directly mg into 2L you can write. M cancelled. Okay, bring this one here. So V square by 2 minus 2GL equal to Vt square by 2. Again multiply with 2 both sides. Okay, so this will be V square. This will become minus 4GL. 4GL. Square root is Vt. So this way we can calculate the velocity of every point. Okay, on the way to top. Bottom then, when they will come bottom, same thing will repeat. This point and this point will have same velocity, this point and this point will have same velocity, this point and this point will have same velocity. That's what conservation of energy, vertical one straight line motion, we saw that. Whatever point when you are going up, whatever is the velocity, when you are coming down, you will have the same magnitude of velocity at that point. Correct? So here also the same. And this is how velocity we are going to calculate. Tension and velocity. These are the two most important points that they ask from in this vertical circular motion. Okay, now what? Now we should know what is the condition in which particle is going to do vertical circular motion. That means minimum velocity that you should have at least at the bottommost point and the topmost point, so that particle can perform vertical circular motion. Okay. So this is our circle. Okay. Now what we want to know? Minimum velocity. Minimum velocity required to complete vertical circular motion. To complete vertical circular motion. So where velocity used to be minimum? Is it the top? So let's talk about the topmost velocity first. So here at the top, Vt is minimum. Then okay. But you should have velocity at the top. This Vt cannot be 0. Why? You require centripetal force, no? Whenever you are talking about circular motion, you have to have centripetal force, then only circular motion possible. So if we are saying velocity is 0 here, that will be centripetal force, centripetal acceleration, 0. Then you can't do circular motion. So you need to have velocity. Okay, so Vt is there. Then we all know that mg is acting downwards. Mg is acting downwards there. Okay, fine. What about tension? We know that tension is least at the topmost point. We know tension is least. We saw that, no? Where it is? Tension here. Topmost point. This is the tension. Okay, so minimum tension is at the topmost point. If I say that tension is 0, okay. If we take minimum tension is there, what is the minimum possible tension? 0 only, right? So tension at the top is 0. Now the condition is, if tension becomes 0, am I still having certain force which can give me centripetal force here? Answer is yes. Mg is there. Mg can balance. So at the topmost point, our condition is Mg gives you necessary tension so that you can complete vertical circular motion. Or tension, rather, Mg is providing you centripetal force here. There is no tension. Then only it will be minimum speed. If you have tension, then what will happen? This will become tight. So this is just straight, not very tight. It is just straight. That means mg is just providing you the necessary centripetal force, because velocity is minimum. Velocity is more, then this value will become more, automatically tension will come. Here velocity is least, that means its magnitude is less. So this magnitude is balanced by mg itself. That is only the condition for the topmost point. Okay, so m Vt square by L equal to mg. M gets cancelled. So what is Vt? Vt is root Lg. So minimum velocity at the topmost point for completing the vertical circular motion is root Lg, root Gr, if we are talking in terms of radius, or in terms of length of the pendulum, then root Lg. Okay. Now, once you know velocity at the top, I want to know what is the velocity at the bottom. This velocity you want now. This is Vb, let's say. What to do? Conservation of energy. What else? Okay. So kinetic energy at the top plus potential energy at the top equal to kinetic energy at bottom plus potential energy at bottom. Okay. Kinetic energy at top, you have already velocity. So half m Vt square plus potential energy at the top. Where is the reference? Again, reference is at the bottommost point only. This is reference. So potential energy at the top means mg into 2L. This is 2L. Height is 2L. So mg into 2L. Kinetic energy at B we are calculating. Potential energy at B is 0. Done. So what we have? First is m, and m cancelled. Vt square by 2. Vt you already have. This is here. So Vt square I am writing as Lg. So Lg by 2 plus 2Gl equal to Vb square by 2. So 2Gl plus Lg by 2, that is 5 by 2 Gl equal to Vb square by 2. This gets cancelled. So Vb value is root 5 Gl. So if you are going to give speed root 5 Gl here, then it will complete vertical circular motion. If you give root 4 Gl, it is not going to complete vertical circular motion. If you give root 3 GL, it's not going to complete vertical circular motion. If it gives root 2 GL, then it's going to do simple harmonic motion, oscillation. Okay, I'm writing it. Okay, so VB is greater or equal to root 5 GL. Particle completes vertical circular motion. Okay, VB is root 2 GL VB, no, not equal to. VB is greater than root 2 GL but less than root 5 GL. Okay, VB is less than root 5 GL but greater than root 2 GL. It will do circular motion. It will do vertical circular motion but not complete. Okay, particle will not complete VCM. But if you are giving speed less than root 2 GL, if VB is less or equal to root 2 GL, then particle oscillates. Okay, note this one. Right. So this is important points for vertical circular motion. Now we are going to find tension. As I told you, tension's values are very important. They ask you ratio of the tension, the top and the bottom. Okay, so what is the tension at the bottom? We already know how to calculate tension at the bottom. So now let's see this question here. Find tension at the top to tension at the bottom if VB, that is velocity at the bottom, is root 5 GL. Okay, so tension at the bottom is what? Let's see one more time. What is tension at the bottom? How we calculate it? This is here. Tension at bottom. What is tension at the bottom? T1. mg plus mv square by L. Okay. Tension at the top. mv5 square by L minus mg. If you can remember this, it is better for us. Okay. See. Now calculate it. So tension at top. Say m velocity at the top square by L minus mg. So at the top, what will be velocity? At the bottom, if it is root 5 GL, at the top, what is velocity? Root GL. Okay, put it here. M root GL square, that means GL, by L minus mg. What is the tension? 0. Tension at the top became 0, that means answer is 0. Right? Yes. Tension at the bottom also you calculate. What it is? M VB square by L plus mg. Okay, so m by L into 5GL plus mg. LL gets cancelled, 6 mg. If suppose it's not asking ratio and directly is asking what is the tension at the bottom, 6 mg. Tension at the top, 0, because that's the minimum for the minimum speed. If it is more, we will get tension. If suppose I say root 6 GL is the velocity at the bottommost point, you will get tension over here. Tension will increase. Okay, so this is how tensions ratio they ask you. They can give you any speed. I have just taken the minimum speed required. Okay. Now, what more questions? They will ask you one more type of question they ask. That question is, if VB is root 4 GL, then find topmost point of particle in vertical circular motion. Particle in circular motion or vertical circular motion. Now we all know that this is not going to complete vertical circular motion because the velocity given is less. But up to what point it was in circular motion? That's what the question asking. Okay, so how to do this? Okay, suppose that this is our pendulum. Okay, and this pendulum now we are saying that it is going to move. So how much it is going to move? Let's say we assume that it will reach here, from here to here. That much only it can do in vertical circular motion. Okay. So that means we are saying this is 90 and little more. Let's say this is theta. Okay. Vertical circular motion is like this. Alright. Length is L. Right. Now at the topmost point, is this point still belongs to circular motion? Answer is yes, it's the topmost point of that circular motion. So that means here also velocity can't be 0. Some velocity will be there. So let's assume here velocity is v. Okay. Then mg is acting like this, we all know. Component of mg, mgl sine theta is here. And if this is still in circular motion, that means there is centrifugal force also. mv square by L will be it. And since it's the topmost point, we can take its tension 0. Because this is the last point in which it is in circular motion. After that, there will be no circular motion. So when circular motion will not be there? When there is no force providing necessary centripetal force. Okay. So here tension we can consider as 0. At the topmost point, tension is 0. So mg L sine theta and mv square by L. Because tension has become 0, this will be balanced by mgl sine theta. Okay. So mv square by L equal to mg sine theta. Gets cancelled. So what is v square? Lg sine theta. Okay. First thing we got. Now conserve energy. This point is A, this point is B. No, this point is B. This point is B. Take this point as then M. Okay. So conserving energy, kinetic energy at B plus potential energy at B equal to kinetic energy at M plus potential energy at M. Okay. Kinetic energy at B half mv square given 4gl. Okay. Potential energy at B is 0. Kinetic energy at M half m v square. Potential energy at M. Now potential energy means from here what height? This is L already and this is what? L sine theta. So we can write here mg L into 1 plus sine theta. Same thing, we have done this before. Okay. So m and m cancel. This is what? 2gl. And this you bring here minus gl into 1 plus sine theta equal to v square by 2. But v square we already have, Lg sine theta. Put it here. So here is 2gl minus gl sine theta equal to Lg sine theta by 2. What are we trying to find? Theta value we are trying to find. Okay. 2gl minus gl means gl. And this gl sine theta, take that side. Gl sine theta plus gl sine theta by 2. That means 3 by 2 gl sine theta. And gl cancelled. So sine theta value that you are getting is 2 by 3. The sine theta is 2 by 3. What the question was asking? Topmost point of particle in VCM. The topmost point is m and its height is what? We can find its height. What is its height actually? L into 1 plus sine theta. Okay. And this is the height. And what is it? L plus L sine theta. So H equal to L plus L sine theta. This is L plus L into 2 by 3. So answer is 5 by 3L. Most common question, root 4gl is the velocity at the bottom, then how much height it can go in vertical circular motion. Root 3gl is the velocity, then how much it will go. The root 3gl I am not doing. Its answer will come 1 by 3. Sin theta will be 1 by 3. You calculate it. Okay. So here height will be 5 by 3l. So that's all. This is vertical circular motion. Okay. Now then what? Now we are going to start power. Just a moment. Yes, students. Next is power. What is power? Power of machine is how much work it can do in a minute or in a second or per unit time. Okay. Work done per unit time or energy delivered per unit time for machines. How much energy it can give. So work done per unit time, power. Power average you can say. W by T2 minus T1 or W by delta T. Its unit is watt. It is scalar quantity, yes. Power instantaneous, you can write as dW by dt. dW by dt. Further, d by dt of F to x. Correct? If force is constant, then we can write this as F into dx by dt. Make like this. So then it becomes force into velocity. It's a dot product of force and velocity. Instantaneous power is dot product of force and velocity if force is constant. If force is variable, then power we'll write as F dV. What else? Okay. If force is variable. So these are the basic things about power. Okay. Its unit is watt or kilowatt. Horsepower is also there. 1 horsepower equal to 746 watts. I have to remember. Okay. So 1 horsepower is 746 watt. And then is one more unit, 1 kilowatt hour. Kilowatt hour is not the unit of power. It is unit of energy. 1 kilowatt hour equal to 3.6 into 10 to the power 6 joule. Okay. Right. So 3.6 into 10 to the power 6 joules. So remember that this is unit of energy, not of power. Power unit is watt, kilowatt or horsepower. Okay. Those are all used for power. So this is how simple questions will be there that we can find with the help of work done. But mostly one common question is there that is asked which gives us difficulty. What is that? That we'll see. So question is there which says the position of the particle. Okay. Position of the particle changes according to the time like this. X is proportional to t to the power 3 by 2. Then find power and time relation. Dependency of power on time. Okay. How to do this? Now, power is what? So that power is force into velocity. Okay. Now this force we can still write as mass into acceleration into velocity. Force we can write as mass into acceleration if it is net force. Okay. Now if mass is constant, just remove that. We can write power is proportional to A and V. A into V. Okay, so to get V now from here, this is x is proportional to t to the power 3 by 2. So V is what? V is actually dx by dt. So V will be what? Differentiation of this 3 by 2 t to the power 1 by 2. Correct. So we got velocity. Now acceleration also is there. One more time differentiation. The acceleration will be what? 3 by 2 here as it is. Then 1 by 2 t to the power minus 1 by 2. Right. So these are constants. These we don't want. We want relation of power with time. So V, what we can write here? You can say P is proportional to A. In place of A, we can write t to the power minus half. V, t to the power half. So P is proportional to t to the power 0. That means P doesn't depend on time. P is constant here. Okay. P is constant. It doesn't depend on time. It does not depend on time. Right? This is clear. So only x is given. With the x, they want to know what is the relation between power and time. We did it. Okay. One more we can see. Here I have taken x to the power 3 by 2. So we got power is not dependent on time. I can take anything else. If suppose I say same question, okay, but with the different values. Say x is proportional to t to the power 5 by 2. Now, how power is dependent on time? Now answer will come. Some answer will come, like previously we said that power is constant, but here it will not be. So we already know power is proportional to A into V now. That I am not doing that, MA into V and all that. Okay. We know this. So what is V here? V is 5 by 2 t to the power 3 by 2. Okay. Then acceleration 5 by 2, 3 by 2, t to the power half. Put it here. So power is proportional to t to the power 3 by 2 and acceleration is proportional to t to the power half. So P is proportional to t to the power 2. Is it clear? So this is a different type of question, different than the normal questions that you have. Okay, like if x is given like this, how to get the relation between power and time. Remaining all questions will be dependent on work done only. So that's why those questions we are not taking. Okay, we can do because work we have done sufficiently, energy we have done sufficiently, so we can solve it. Okay. Then what? Now we are going to see collisions. Collisions. Okay, and little bit of concept of center of mass. How to calculate center of mass. Before that, before starting collision, we will go for center of mass. Okay, so we all know that if suppose there are two masses, m1 and m2, and separation between them is r, and we want to find center of mass, what we do? I have a formula. Say m1 x1 plus m2 x2 by m1 plus m2. And center of mass basically is what? Center of mass is hypothetical point where we assume that the mass of the system is concentrated. Now system means what? This particle and this particle together is called system. So where exactly we can say the entire mass is concentrated? That point is called center of mass. Hypothetical it is? Yes, it is hypothetical. Okay. So m1 x1 plus m2 x2 by m1 plus m2. Now, before we calculate x1 and x2, we should know where is the origin. So, anywhere you can take origin. Normally, we will consider any one of the particle as origin. So, this is origin. So, its coordinates will become what? R comma 0. Now, we can calculate. So, m1 into 0 plus m2 into R by m1 plus m2. Answer is m2R by m1 plus m2. m2R by m1 plus m2. That's the position of center of mass. Okay, fine. We can calculate it for anything. Yes. Now, where will be center of mass out of the two? Where it will be closer? So, if suppose m1 is greater than m2, so m1 is greater, so center of mass will be closer to heavier mass. Okay. Center of mass will always be closer to heavier mass. It will always be closer to heavier mass. Okay, so this way we can find it. If suppose it's along y-axis, we can do m1 y1 plus m2 y2 by m1 plus m2. And if it is having both the coordinates, x1 also is there, y1 is there, x2, y2, then we can do it twice. For x1 first we will find, y we will find next time. Okay, so this is how we find center of mass. Certain uniform bodies are there where center of mass we should know. Okay, normally those questions are not asked. Okay, I have not seen that at least, but there are few that we should know. Like if suppose we are talking about rod, so its center of mass will be where? At the center itself. So uniform rod, its center of mass is at the center. Okay, here is center of mass. What is that? L by 2. Ring is there. Uniform ring, its center of mass is at the center. Disk is there. Ring, disk, sphere. Okay, so that means if symmetrical bodies are there, it will be at geometrical center. Yes. For all symmetrical bodies, objects, center of mass is at their geometrical centers. Like triangle is there, triangular plate is there, it will be at its centroid. Rectangle is there at centers, square is there at center. But if suppose that we are going to change its symmetry, okay, its shape, like we say semicircular ring. A semicircular ring means it's not symmetrical. Semicircular ring we have. Okay, so this you have a semicircular ring. Now, if this is a ring, it is symmetrical. Symmetrical about x-axis also, symmetrical about y-axis also. But when you say semicircular, then obviously it is symmetrical about y-axis, no doubt about that. But it is not symmetrical about x-axis. If this is x-axis, you have above something, but below nothing is there. It's not a symmetrical thing. But about y-axis, it's symmetrical. There is no doubt about that. Okay, there is a symmetry about y-axis. Both sides similar. So what will happen? Its center of mass will be on y-axis. Here only its center of mass will be. Somewhere here normally, but it will be on y-axis only. Reason? Symmetry is there. Whatever mass is here, same mass is here. Okay, so it will be exactly in the middle. Right. But here question is, what is its y coordinate? X coordinate we said 0. If suppose we are saying this is origin, then its x coordinate is 0. But what is this? This is 2r by pi. Okay, 2r by pi where this is radius. Okay, for ring, if the same thing becomes disk, then semicircular disk, then its center of mass coordinates. Diagram will be same, that's why I am not making. Center of mass will be 0, comma 4r by 3 pi. 0, comma 4r by 3 pi. Okay, just remember this. This is 2r by pi, this is 4r by 3 pi. If it is a sphere, then sphere's diagram we can make one more time. Hemisphere we have to make, right? So hemisphere, right? So hemisphere if we are making, okay. This is hemisphere. Okay, radius is r. So its center of mass will be where? Again, at certain height on y-axis, because again about y-axis it is symmetrical. So if we consider this is 0 here, then what is the coordinates of this? 0, comma 0, comma 3r by 8 for solid hemisphere. Solid hemisphere. If it's a hollow hemisphere, then r by 2. Okay, for hollow hemisphere r by 2, for solid hemisphere 3r by 8. These are just few values that if it you know, it will be better for us. Okay. So these are which center of masses? Non-symmetrical bodies. Okay, right. This was center of mass. Then what is most important in this? Most important is conservation of momentum. What is conservation of momentum and where we have to apply? See, if we are talking about a system at least of two particles. Okay, two particle system is there. Two particle system. That does not mean that three particles cannot be there. Three particles also can be there. Okay, the two particle system. And two particle system, in this one, both the particles are applying force on each other. Then for a system, that force is internal force. Okay, so that force is called internal. But if suppose that there is no external force acting on the system, which can change the momentum, because we saw the second law of Newton, force is equal to change in momentum per unit time. So if force itself is 0, change in momentum will be 0. So that is what this law is all about. Okay, if there is no external force, if there is no external force on the system, then momentum of system remain conserved. Momentum of system remain conserved. Okay, momentum will remain same only. Whatever was the momentum earlier, same will be the momentum later on. Reason? Because you have not applied any external force. So what type of questions are asked on this one? Questions are asked on recoil velocity in this. What is recoil velocity? Let's see the question, you'll understand. If suppose that we have a small gun. Okay, gun is there. Something like this. Okay, its mass is m. Okay, then we fire a bullet in that one. That bullet is here of mass small m. Fire it with velocity v. The question is asked from you, Find recoil velocity of piston. Find recoil velocity of piston. So the question here is now, before firing, what was the momentum? Just before firing, 0. Just before firing, bullet did not come out. Just after firing, this is having velocity. Okay. Anybody applied any external forces there in that? No one applied external force. Has anyone applied external force on the bullet? No. Anyone applied external force on this gun so that it can move forward or backward? No. Nobody applied. Okay. So we will say that no external force is applied just before and after the firing. After the fire. Just before fire, what you have done? You have already compressed the spring. Because you have no here. This trigger. So trigger, what you do? Press it like this. What you have done? You have compressed the spring. Already compressed. Okay. So once spring is compressed, now that is your initial stage. Compressed spring is your initial position. Right? Anybody is moving before that? Anybody is moving now? No. Now when you are going to release the spring, then only bullet will go. So here when we say no external force is applied just before and after, that means spring is compressed and release. Any external force is there? Spring compress and release? No. At that moment, no. You can't say that before that you are compressing the spring, that external force I applied. We are not taking that into account. What we are doing? Just before and after. Just before firing, what happened? Spring was compressed already. Okay, and just after, you release the spring. So in that one, any external force is there? No. Okay. So initial momentum is what? Initial momentum C. Final momentum? Final momentum, pistol is going to move separately and bullet is going to move separately. So we'll write momentum of bullet plus momentum of pistol. What is momentum of bullet? M into V. Okay. What is momentum of pistol? Say M into Vp. Okay. But these two are equal. Why? Because no external force is there just before and just after. Okay. So equate it. This is 0. Mv plus Mvp. So what is Vp? That is only recoil velocity. Vp is minus Mv by n. What is this minus stands for? Minus stands for means this velocity is positive, this velocity is negative. So the pistol will go like this. That's why it's called recoil velocity. Okay, like this, we have to solve this question. Conservation of momentum. Okay. Other type of question that are asked, explosion. Questions on explosions are asked. Explosion is what? Suddenly one particle, okay, when it explodes, multiple particles will come out from that. Okay, one particle is there. Suppose in Diwali also we have seen that. Okay, we have a bomb, we are giving fire to that one. What happens? It explodes. It explodes, then multiple particles will go here and there. But that multiple particle we are not talking here. We will talk only about 2 or 3 particles that will come out of explosion. But just before explosion and just after explosion, have you applied any external force? Answer is no. So momentum is conserved. Okay. So in explosion also, momentum just before and after, just before and after explosion is conserved. Just before and after explosion is conserved. Okay, now let's take an example. Let's solve one question on this one. Now suppose one particle is at rest. Suppose this is our bomb, mass is m. It is at rest. Now it's going to explode. Okay, it's explosion. Now let's assume that 3 particles came out of that. One particle m by 3, all equal. M by 3 is going like this. One more m by 3 is there, that is going in this way. Okay, we want to know where is the third m by 3, where it is going. So let's assume its velocity we are giving as v. This also you take v. The question is asking us find velocity of third particle. That's the question. Okay, what to do? Before explosion, what is the momentum? 0. Okay, initial momentum before explosion. 0. After explosion momentum, what is happening? There are 3 particles. So we'll say m by 3 v I cap plus m by 3 v j cap, and third one we have no idea. Let's say v1. Okay, but momentum is conserved. That means initial momentum and final momentum we are going to equate. No doubt about that, right? So equate it then. Okay, here only we'll do. So I'll just remove this one. Right. So equate it. We say Pi equal to Pf. This is 0. This is m by 3. I've taken common. This is Vi plus Vj plus V1. So this also will go here 0. So we'll bring this one this side. What it is? Minus V into I plus J equal to V1. Right. Now we want magnitude. Magnitude we want. Velocity, value and its direction we already got. Minus V into I plus. This is the direction. So that means it's along minus I, it's along minus J. So that means it's somewhere here. This is definitely velocity, V1. Okay, m by 3, remaining m by 3 is going in this direction. How can I say? Because it's there, no, minus I plus J. And this also I know because minus I plus J is there. That means I's magnitude and J's magnitude is also same. So that means this is definitely 45. That also we know. But what is its magnitude? That we have to find. Okay. So see now how to find its magnitude. This is also V, this is also V. That means along x-axis also its value is V. And along y-axis also its value is V. Okay. Correct? No. Just forget about this negative at the moment. Only concentrate here. Vi plus Vj. So along x-axis also V, along y-axis also V. So what is the resultant? Resultant is here. And since they are perpendicular to each other, we know that what it is. What it will be? Root 2V. V1 will be equal to root over V square plus V square. That is root 2V square. That is V root 2. So what is its magnitude? V root 2. So our answer here is V root 2 is the magnitude of velocity. Direction you already have. Is it clear? Right. So this is how explosion questions will be coming to us. Okay. That's explosion. Explosion can happen in air also. Projectile also question can be added into that one. So what do you do in that case? Before explosion, projectile's velocity we can calculate. And then afterwards, suppose in projectile we are going to apply this. For projectile. Okay. So in projectile, suppose at the highest point, this ball is going to explode. And it explodes into two parts, maybe m by 2 and m by 2. So they will say that m by 2 is having what velocity? One velocity will be given. M by 2 remaining parts velocity we have to find. What to do? Simple. Before explosion, what is the momentum? We have to talk about that first. Okay. Let's say mu cos alpha. This angle is alpha. This is u. So at the topmost point, we know its velocity will be u cos alpha. Initial momentum. Okay. The vector we have to write, then I cap will be. Then final momentum. They will tell you m by 2 is something, its velocity is what? They will give us. Okay. So if they are giving us, suppose v1, I am saying just taking it. And they will ask you that what is the velocity v2. So okay, fine. Pi equal to Pf, we will be getting v2l. Okay, so in projectile also we can do the same, no problem. We have to just apply conservation of momentum. Whenever explosion is there, apply conservation of momentum. Okay, right. Now we are moving on to collision. Okay, collision. Suppose this is m1, velocity u1. This is m2, velocity u2, and they are going to collide. Now collision is possible when? Collision is only possible when u1 is greater than u2. Then only it will collide, because u1, this m1 is behind m2. Okay, so collision is only possible if u1 is greater than u2. Correct? Collision happens. After collision, what happens? m1, v1, m2, v2. Now what is going to happen? Here v2 has to be greater than v1. So you see that velocity is what happened. Earlier u1 was more, now v2 is more. So velocities are getting exchanged. Who is doing it? Force. Who is applying the force? Because two balls are having collision. So this M1 is applying force on this ball, like this. Okay, and M2 is giving the same force in backwards direction. Normal contact force, action reaction, same value. So because of this, first ball decreases its velocity, first ball's velocity gets decreased, and second ball's velocity has increased. V2 is greater than V1. Here it was U1 greater than U2. This is what happens in collision. But in this process also, if I am talking about these two particles alone, any external force is there? No. So here also momentum is conserved. Okay, momentum is conserved in collision. All types of collisions, yes, because I didn't talk about what type of collision it is here. All type of collision, momentum is conserved. Right? Now, how many types of collisions are there? Three types of collisions. Three types of collisions. Elastic, elastic collision, perfectly inelastic collision, and partially elastic you say, or inelastic collision you say. Partially elastic or inelastic collision. So three types are there: elastic, perfectly inelastic, partially elastic. In all of them, momentum is conserved. There's no doubt about that. But other than that, when you're talking about elastic collision, okay, in elastic collision, what happens? Elastic collision. Okay, in this collision, kinetic energy is also conserved. Before collision, whatever is kinetic energy, after collision also kinetic energy used to be same. Okay, so in this one, yes, momentum is conserved. We can say m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Momentum is conserved, but at the same time, kinetic energy before collision is equal to kinetic energy after collision as well. Kinetic energy after collision. Okay, that means half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. Okay, this is also there, this is also there. Both are there. And based on these two, what type of question will be asked from elastic collision? They'll ask you either V1 or V2, or maybe both. U1, U2 will be given to us, V1, V2 they'll be asking us. So in this case, we have to remember a formula. This is all concept as far as momentum is concerned. We have to remember the formula. Suppose, and say same diagram I am making again. This is U1, M2, U2. Okay, collision happened. After collision, this is M1, V1, and this is M2 and V2. So what they'll be asking us, V1 and V2 values. So what is V1? This formula you have to remember. Okay, M1 minus M2 by M1 plus M2 into U1. You can put it vectorially also. There is no issue in that. V1 equal to M1 minus M2 by M1 plus M2 into U1 plus 2M2 U2 by M1 plus M2. Okay, V1 you are doing, so M1 minus M2. In the denominator M1 plus M2 here also, here also. Okay, for U1 and U2. How you can remember that? Right here U1, right here U2, right denominator M1 plus M2, here also M1 plus M2. Now since you are doing for V1, so right here M1 minus M2. Okay, M1 minus M2. Here it's for U2, so write it as M2 plus M2. M1 minus M2 here, M2 plus M2 here. Whichever way this is all you have to remember. If directly you can remember, fine. Okay, right, this is V1. Then V2, same way. If you remember V1, obviously V2 you can write automatically. What will be difference here? V2, I'll be writing M2 minus M1. So M2 minus M1 by M1 plus M2 into U2 plus 2M1 U1 by M1 plus M2. This is here. So this will give us answer of all the questions that we want. If elastic collision is given, apply this, you'll be getting the velocity of all. Okay, but at the same time, other than this, remembering this formula, we also should know kinetic energy before collision and kinetic energy after collision is equal in elastic collision. Okay, so this formula is important. Let's do a question on that one. Now suppose that elastic collision we are talking here is mass m and this is moving with speed 4 meter per second, and another one is there, this is 2m and it's moving with the speed of 2 meter per second. So after collision, what will be their velocities? Okay, find velocities of balls after collision, after elastic collision, perfectly elastic collision. Okay, this is given. Fine, let's apply the formula. V1 m1 minus m2 by m1 plus m2 into u1 plus 2 m2 u2 by m1 plus m2. Let's put it. What is m1? m1 is m. m2 2m. m plus 2m 3m. ui, so 4i cap you can put. Plus 2m2, that is 2 into 2m by m1 plus m2, that is 3m into u2, just 2i cap. Okay, so what is here? Minus m by 3m, that is minus 1 by 3. So minus 4 by 3 I cap plus, here also this is this cancelled. 2 into 2 into 2, 8 by 3. So 8 by 3 I cap. So it will become 4 by 3 I cap. This is V1. Same way V2 we can do. V2 is M2 minus M1 by M1 plus M2 into U2 plus 2M1 Q1 by M1 plus M2. So M2 is what? M2 is 2M. 2M minus M by 3M into 2I cap plus 2 into M by 3M into 4I cap. What we are getting here? This is M by 3, so 1 by 3, so 2 by 3. 2 by 3 I cap plus 8 by 3 I cap. This is 10 by 3 I cap. So V2 value is 10 by 3 and V1 value is 4 by 3. If they are moving in opposite direction, then what? Opposite direction, minus 2 I will write over here. What else? No problem. Okay. So take in vectors so that you are not having any problem, right, in adding or subtracting. This is about elastic collision. Then perfectly inelastic collision. Perfectly inelastic collision. Perfectly inelastic collision, what happens? After collision, both colliding objects will have same velocity. Okay, they will have same velocity. Normally we say that both stick with each other. Okay, after collision, both objects stick with each other. That means they will have same velocity. Okay. Alright. So in this case, if this is m1 and speed is u1, here is m2, speed is u2. After collision, what's happening? After collision, this is happening. m1, m2, and they will have speed u. Okay. So momentum is conserved here. Yes, momentum is conserved, no doubt about that. So momentum is conserved means what we can do? Before initial momentum m1 u1, this is m2 u2, and final momentum m1 plus m2 into u. What is u then? Okay, u equal to m1 u1 plus m2 u2 by m1 plus m2. If they are all in same direction as I have made, So directly we can add m1 u1 plus m2 u2 by m1 plus m2. If they are vectors, we will see how vectorially we can add. Okay. So m1 u1 plus m2 u2 by m1 plus m2, this is the velocity. Right. In this one, kinetic energy not conserved. There is loss of kinetic energy. Okay. So kinetic energy is not conserved in perfectly inelastic collision. Perfectly inelastic collision. In fact, there is loss. So how much is loss? You can see that. Kinetic energy loss will be what? Initial kinetic energy half m1 u1 square plus half m2 u2 square minus half m1 plus m2 into u square. That is only the loss. So how much loss will come? If we can remember formula, better for us. But meaning you should know. Initial kinetic energy minus final kinetic energy, that is only the loss. Okay. What is the formula? Half m1 m2 by m1 plus m2 to u1 minus u2 whole square. Okay. u1 minus u2 is basically, if suppose they are in opposite direction, you should be adding them. So I will make it as vectors. Okay. So half m1 m2 by m1 plus m2 into u1 minus u2. So this is kinetic energy loss formula. Whenever inelastic collision is there, there is kinetic energy loss. And what is perfectly inelastic? When both the bodies are going to stick with each other. Okay, that's perfectly inelastic. And then partially inelastic was what? Or partially elastic is what? Partially elastic means partially elastic means what? In this one actually, if we try and understand all type of collisions, what happens in perfectly elastic collision? When the bodies are colliding, when the bodies collide, we know that during collision, both the objects are applying force on each other, and because of applying a force, bodies get deformed. Whenever you are going to apply a force, what happens? Body deforms. But as they separate from each other, body regains their shape. In which collision? First one, perfectly elastic. Again, listen. When suppose my hands are showing you two objects. Okay, so they are going to collide. So during collision, what happens? They get compressed like this because both the bodies are applying force on each other. And when the contact is removed between them, then what happens? They become same. However, they will be regaining their shape. In first type of collision, perfectly elastic collision. Perfectly inelastic, what happens? Again they came and then they are together after that. They are going together like this. So could they regain their shape? No. It is like this one. Okay. Third type of collision, again they are colliding. Okay. Then they regained a little. Now this became like this. Now they regained a little. And they again separated from it. Like this they separated, not the original shape. Like this. So this is third type of collision. Partially elastic or inelastic collision. Okay. So in this one, what to do? If suppose they ask us velocities, how we will find? That you will see. But in this one also, momentum is conserved. Momentum is conserved in all type of collisions. Remember that. Okay. So momentum is conserved. Okay. Second, kinetic energy is lost. Kinetic energy is conserved only in perfect elastic collision. Here kinetic energy is lost. Here we have something new also. What is new? Coefficient of restitution. Coefficient of restitution. We represent with E. Now what this is? This is actually velocity of separation by velocity of approach. by velocity of approach. Velocity of separation obviously happens after collision. So we write this V2 minus V1. And approach, we write this U1 minus U2. This is E. Okay, and this E for perfectly elastic collision is 1. This is 1. Perfectly inelastic, 0. Because they don't separate. In inelastic collision, what happens? They don't get separated, both sticks. So then V2 minus V1 will become 0 in perfectly inelastic. This is 0. But in this case, partially elastic collision, E is less than 1 and greater than 0. That means it's in between, okay? Right. So E value is between the two in partially elastic collision. Now the question is how to find velocities in this case, because here also they are separating. So same formula that I told you for elastic collision, no? In that one only, little change will be. This is V1, see. How to write it? M1, how it was? M1 minus M2 by M1 plus M2. So M1 minus EM2. That is it. M1 plus M2 into U1. Then what we written? 2M2, right? 2M2 will write. Now write M2 plus EM2 to U2 by M1 plus M2. Okay. Then V2, same way. M2 minus EM1 by M1 plus M2 into U2 plus M1 plus EM1 by M1 plus M2 into U1. That's all. Apply this formula. Whatever question is asked related to velocities after collision, we can find it. Coefficient of restitution value they will give. If they are not giving coefficient of restitution value and they are asking coefficient of restitution, then they will give us V2 and V1 value. So then we'll use this formula. Okay. So either this they will give or E they will give. So accordingly, we can use it. Okay. So these are the three types of collisions and the formulas. In collisions, you have to remember this formula other than the concepts. Okay. So this way, work power energy finishes today. Right. Tomorrow's class, we are starting rotation. Okay. So today, I will be posting question paper or test paper on work power energy. Okay, students. So that's it for today. Bye-bye.